Hello. This is video 46. I'm starting way up in the corner because this is probably going to take up a lot of board space. This is another example of a program trace. This is a trace of example 2.py. And you'll recall a trace is where we behave like we are the CPU, executing a program one line at a time, keeping up with all the values of variables and the output that's produced and everything. So it's really a way to predict what the program will do when we run it on a computer. That's what we're trying to do. Example 2.py, you'll notice, has a much larger header block. There's a lot going on up there. Let me read through this quickly. It's going to read a list of non-zero integers. I don't know that I'm going to remember all this. Counting the negatives entered and finding the average of the positives entered. I don't need to remember it anyway because we're going to do it one line at a time. It's probably better if I don't remember it. Things to look for. This illustrates, starting on line 8, illustrates basic usage of an if-else statement. Been there, done that. While loop with sentinel. That's a new word. Watch out for that. A counter, a running total, nested statement blocks. You know what? Those are all things that are going to make more sense after we have gone through the program, and then we can reflect back over it and say, ah, yes, that's what that was. So those are things to watch out for. There are I don't think there are any new types of Python statements in this. It's just using them in more sophisticated, conventional ways. And remember, convention is a way that we all agree to do it that way. We all agree to have a header block of comments at the top of the file, because if we follow conventions, not only looks more professional, it makes it easier for us to read each other's programs. So def main starts on line 16. And I'll do the dividing line thing again. We'll see how well this works. Output over here. The actual variable trace over here as variables show up, and I keep up with their values. The output starts with a blank line, and I'm going to use a smaller font to see if I can fit more output on this. I hope it's still legible. Then it prints out integer list processor. An integer is just a whole number, by the way, no decimal fractions. Integer list processor. And then another blank line after that. Then blank line in the code, but that doesn't result in a blank line on the screen. Now, glancing through this, I'm going to violate my own Leaf Tree Hill principles here of going exactly one line at a time. These are no good. There's a before, during, and after here. This whole program is kind of constructed around the while loop. The while loop is the center of attention. But there are things we need to do before we get into the for loop to get ready to go. There are things we do during the loop. That starts on line 31. And then there are things we do in summary after the loop. That's on line 44. So there are three main pieces, three main logical divisions of this program: the before, the during, the after. Before the loop, get everything set up, initialize counters. Here's what a counter does. A counter goes 1, 2, 3, 4, 5. You knew that. A counter keeps up with how many of something. Counters and running totals. A running total might be, well, let's see, I spent $15 yesterday. I spent $20 today, so far my running total this week is up to $35. I'm going to spend $5 tomorrow. My running total will be up to $40. So a running total also adds up numbers as they appear one at a time. It's just not going to always be one. A running total adds several different quantities together. A counter adds one every time. There we go. Now we've got variables all over the place. Negative count is 0. Almost always, actually I can't think of an exception, almost always we will need to initialize both any counters that we're using to 0 and any running totals that we're using to 0. So that's just our baseline, that's our starting point, and that's what's going on here. I initialize the counter of the negative numbers to 0, the counter of the positive numbers to 0. Positive count is set to 0. Now of course the CPU, this goes without saying, I'll say it anyway. The CPU doesn't know what we're going to use these for. We came up with these variable names so that it made sense to us. I can look at this and think, you know what? I bet that's going to be a counter of positives. What about that? Yeah, I bet that's going to count negatives. That doesn't make any sense to the CPU. It doesn't know what our intent is. That's entirely up to us. And then positive total. I better put that down here. These are probably going to change. Positive total. Now notice this judicious choice of variable names. Positive total is 0. I don't know that it's a deeply held convention, but it's a good idea to name your counters something that sounds like a counter, like positive count or negative count. And to name your running totals something that sounds like a total, like positive total. So those variables to some degree are self-explanatory. There. Then that's the before part, and also there's another piece, tiny little piece of before part. We're going to read something before we even start the while loop. Line 28 is one of those input statements that's reading a number. It says enter an integer 0 to quit. Enter an integer. And then in square brackets, we'll tell the user how to stop the loop. 0 if they want to quit. 0 to quit. Close square brackets, colon, space. And it's just going to sit there. It's going to sit there and wait for the user to type in a number. And let's say our user types in 25 and presses enter, which I'll indicate with a little curvy arrow like that. What happens to the 25? Well, now we're ready to look and see. I might as well leave the cap off the blue. I'll be using both of these. What happens? I'm stalling. Now, I'm back. Enter an integer. It reads it in with the input statement. It evaluates it into a 25 and puts it into a variable called number. Here it is, number. Now has value 25. Just now read in and converted with the eval into an actual number. Why? Why do we do that? We hadn't even started the loop yet. Well, that's exactly why we did that. We're kind of using it to prime the while loop. Let's get going here. But we need to have a number to test by the time we get to line 29. That's a standard pattern. I'll talk about that after we've looked through more of the pattern. But just remember, we'll need to read a number first before we start our while loop, if we're going to use the while loop to read all the numbers for us. While number is not 0. If they had typed 0, we would have quit immediately and never executed the while loop. They didn't. They typed in a non-zero, so the condition on line 29 is true. Number, that value 25, that's not equal to a 0. So away we go. We're inside the indented statements of the loop. During the loop, let's get busy here. Line 33. Well, first of all, let me read the comment and see if we can get our mindset for what's supposed to happen here. During the loop, do everything that needs to be done for one number. As we're going through the loop, each time we go through the loop, we'll have a new number that was read in. So now we're going to do everything. We're going to turn 25 every which way but loose. Do everything we possibly might want to do to 25. Starting with line 33. Is the 25 that's in number, is that less than 0? 'Tis not. So we skip over that, and well, the computer skips over that, and we're going to do it too because we're emulating the computer. And we do line 37, starting on 37 instead, because this is an if-else, a format to if. So it's going to do both of those lines that are indented under else. Line 38 says, start with positive count on the right-hand side, positive count 0. Add 1 to that, mental note. A mental register up here. The right-hand side is 1. Take the 1 and put that back into variable positive count, also known as incrementing positive count by 1. Oddly, perhaps, line 39 is also an increment statement, but it's not adding 1. When we increment a running total, we add some number to it. It could be 1, but it also could be something else. In this case, on line 39, it takes the current value of positive total, which is 0, the current value of number, which is 25, adds those together and gets 25 as the grand total and puts that in positive total. So we incremented both positive count and positive total, but positive count only went up to 1. Positive total, the running total, went up to 25. Now we've done everything we want to do with 25. So it's time to get another number. Here's the pattern. Process, 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 all the way through the while loop. All of that chunky code right smack in the middle of the program. When we're finally done, the last thing, the very last thing, after we've done everything we can do to 25, is to read the next number. Why do we make that the very last thing? Because we know the very next thing that's going to happen is it's going to go back up and test that condition again. Watch this. Line 42 says, another integer. Now, they can still type 0 to quit, but we don't want to browbeat them with that. We don't want to insult their intelligence and keep telling them that over and over. So they could look on the screen and see that, well, if I want to stop here, I could type in 0 if I wanted to. Maybe they don't want to. Maybe they want to type in -3. -3 and press enter. Now, let's just say they do that. If they do that, then the very next line that's executed after line 42, after it's read in the -3 and store. Oh, I better get my act together over here. It's read in -3, but I didn't put it on the left-hand side. It's the new value of number, wiping out the 25. So we've got a new number we want to take a look at as of line 42. Now I'm ready to go to the next line. I was just in such a hurry to get back up there. Back up to line 29. It goes back, since this is a while loop, and checks that condition again. Is it true that number is not equal to 0? Yes, it's true. -3 is not equal to 0. So it goes through a loop again, skips over the comments. Line 33 says, if number is less than 0, well, guess what? This time it is. -3 is less than 0, so it is going to do the indented part after the if statement, and it's going to skip the else. The line 34 says take negative count, which is 0, add 1, that's 1 now. Make that the new value of negative count. So now negative count is up to 1. Skips over all of the else part, and now we've done everything we want to do to -3. Gets back down to 42 again already. Line 42 says another integer. Colon space. And let's say the user types in -34. Presses enter. There doesn't have to be any pattern to the input. We'll just take whatever they can throw at us, as long as it's an integer, positive or negative or 0. They just typed in -34. Let me see if I can get that right this time. They typed in -34. It runs it through the input into the eval and becomes a real live -34, 2's complement value with a bunch of 1s up front. We know that. And puts it into variable number. -34 is the new value of number. All that was line 42. That's the last indented line inside the while loop, so it goes back up to line 29. Is it true that number is not equal to 0? Yes. -34 is not equal to 0. Is it true then on line 33 is number less than 0? That's also true. -34 is less than 0. So it hits line 34. Negative count plus 1 on the right-hand side. Negative count is currently 1 right now. So it adds 1 to that, it makes it 2, and stores that back in negative count. The new value of variable negative count is 2. And we're just about done here with that one, because it skips over the else. Since it did the true part, it skips over the false part. And it gets back down to line 42 again. Input another integer. Yes, we are definitely in a loop now. Colon space. And let's say the user types in 14. Presses enter. If they do that, that 14 goes to the left-hand side of the assignment statement, becomes the new value of variable number. Been there, done that. We've heard this all before. We're on a loop ourselves, are we not? So after line 42, goes back up again. It'll go back up every single time to line 29. Is it true that number is not equal to 0? Yes, it's true that number is not equal to 0. Is it true on line 33 that number is less than 0? No, it's not. Now notice the else is only going to execute for positive numbers. It's not going to execute for 0. It's not going to execute for negatives. It won't execute for negatives because the number less than 0 test on 33 takes care of that. It's not. Here's the more subtle part of that. It's not going to accidentally count 0 among the positives. Why not? Because if they had typed in line 0 the last time we had hit line 42, then it's going to jump out of the while loop on line 29, and we never get to the inside of the while loop. So we know for a fact by the time we get to line 38, we definitely have a positive number here. Positive count plus 1 will be 1 plus 1, also known as 2. That gets stored back in positive count as value 2. Positive total equals positive total plus number. Positive total plus number, I can do that math. I'm going to get crazy here if I'm not careful. 25 plus 14 will be 39. Snapshot. So far we've read 2 negative numbers, 2 positive numbers, and the sum of all the positive numbers that we've seen so far is 39. See what these variables are doing for us? Our counters and our running totals. And number, that's just the number, that's the one in the spotlight at the moment. It doesn't know anything about what's going on in the grand scheme of things except what the last number was that the user typed. I got off track, didn't I? That was what, line 39? Unfortunate, man, life is full of unfortunate coincidences. Line 39 assigns positive total to be 39, not because it's the line number, but because that's what the total is. Okay, back to line 42. Notice we get to line 42 regardless of whether we do the if or the else. Why? Why? Because line 42 is inside the while loop. It's indented that much, but it's not indented to be part of the else or part of the if. So it will be done every time we go through the while loop, regardless of whether or not the number is positive or negative. So it prints out another integer. If we're not careful, we're going to scroll off the screen and the user's going to forget how to quit. I just won't let it go, will I? I don't want these to be the same. So let's do 17. Press enter. Just to mix it up so we don't have any more unfortunate coincidences. Typed in 17, that goes to the left-hand side of the assignment. Number becomes 17. It's at the bottom of the while loop. It goes back to the while loop. While number is not equal to 0, it says on line 29. And no, 17 is not equal to 0. Is it true on line 33 that number is less than 0? No, that's not true. Is it? Well, then we don't do another test. Oh, I'm glad I almost said that. Don't retest. Don't say else if number is greater than 0. Trust the else. Trust the else to cover up all the mess left by a false if statement. If else covers all possibilities for the value of number. So don't do an additional test to make sure you've got a positive. There. I'm describing in a loop as well, am I not? 17 was not less than 0, so it falls through to the else. It says positive count plus 1 on the right-hand side. Positive count plus 1 will be 3, and it stores that back in variable positive count, so that's a 3. And here's the sum for me. Positive total plus number on the right-hand side of line 39. Let's see, it ends with a 6. 3, 4, 5, 50, 56? I think that's what it is. 16, 1, 2, yeah, I think it's 56. If it's not, I'll send you an email with the correct answer later. Where are we now? We read a number again. You know what? The user, you, I, we're all getting a little bit tired of this. Another integer. Oh, if only we knew how to stop. I think we do. Way back in time, it said 0 to quit. Let's trust the program or the programmer and type a 0 because we want to quit now. It's on line 42, asking for another integer. It evals, turns that into a string of 0 bits, also known as 0. That is on line 42. It still goes back to line 29 all over again. While number is not equal to 0, but look, number is equal to 0. So the condition on line 29 is false. Finally, mercifully, the condition is false, and it means that we don't go through the while loop anymore. We fall out of the while loop and go to whatever follows the while loop. I hit a chunk of comments here on line 44. After the loop, summarize everything. First thing, find the average of the positive integers and then print out all results. Well, let's see here. Line 46, notice I'm unindented. I'm indented at the same level as the while loop because I'm still inside the main program, but I'm not inside any ifs or whiles or anything. If positive count's greater than 0, positive count is greater than 0. Positive average then would be equal to, look at how we can use running totals and counters. Line 47, positive total, the running total divided by positive count. That's how many positives there were. 56 divided by 3. One moment, please. 56 divided by 3. 1 times 2 is 3. 26. 3 times 9 is too much. 3 times 8. 3 times 8 is 24. 2 point. This is me doing math over here, by the way. You don't have to watch this. I'm just trying to come up with what should be printed out on the screen. 3 goes into 20 6 times, and it's going to be 2 left over. 6, 6, 6, 6, 6, 6, 6. So it's going to print out for the app, which I'm not going to print it out yet. We haven't told it to. It's going to take the right-hand side of 47 to be the value 18.666 repeating forever, and put that into positive average, a new variable that I didn't leave room for. Here it is, positive average. Is, I hope, 18.66666 repeating, also known as 18 and 2/3. 2/3 is 0.6 repeating. Now look at the else part here. What is that trying to do? If positive count is greater than 0, in other words, if they typed in at least one positive number before they typed in a 0, that's what that's indirectly asking, then calculate the average the way you'd expect. Divide the grand total by how many there were. Else it just says the positive average is 0 without doing any calculation. What that's doing is trying to keep the program from crashing. If we tried on line 47 to divide positive total by positive count, when positive count is 0, it doesn't matter what the value of positive total is. If we divide by 0, that's going to crash the program. Even Python can't divide by 0. Your calculator gives you some weird value as well. So that's just catching the very special case that no positive numbers were typed in. Okay, then after it does a calculation, we still haven't seen that on the screen. It prints out a blank line to make everything look pretty. The /t, that's a little insider tip there on line 51. /t means tab over. I'm going to represent that by just drawing that straight line right there. There were negative count. Negative count is 2. There were 2 negatives in the list. Period. Goes to the next line, /t. It's going to tab over again. And you're not going to see that line on the screen. That's just a visual cue to me that I need to start writing over here instead of at the first column. The average of the then the value variable, positive count, 3. The average of the 3 positives is prints out positive average. That's the 18.666 for however many 6s the computer wants to print. I'll just put 3. And then a blank line. And that's it. That's all there is to it. Well, that's a lot, isn't it? But what did it do? It counted the negatives. That's all it wanted to know about the negatives. It didn't care about the average or anything. It had to count the positives, because not only did it print how many positives, but it also printed out what their average was. The average of 25 and 14 and 17. And I just now realized this little underline thing, that looks like a minus. That's dangerous. There. Look at that. Look at that as opposed to the way it was before. Now it's much more clear which are the negatives and which are the positives. Now then, as promised, let's go back to the header block and see if we can figure out what the hey those things are talking about. Line 9. I hope you have line numbers in the editor that you're looking at. If you don't, you might want to open it in Notepad++ or something like that. I think that shows line numbers. You don't have to strictly stick to the Python editor for these things. Line 9 says if/else statement. It's not on the board. I don't know why I'm looking there. The if-else statement are lines 33 through 40. We've seen that. We've done if-elses. While loop with Sentinel. Sentinel is a special term that just means a garbage value, a value that we don't want to use. to kick us out of the while loop. It's one that we intentionally feed in during the input just to stop the while loop. In this particular case, the sentinel value was 0. When you want to stop, type a 0. Now you'll notice, after they typed a 0, it did not go back and add anything to the counters of the running total or anything like that. This was purely entered to stop the crazy while loop from going around in a circle, for crying out loud. That's all a sentinel does. I think the real sentinel is like a doorway guard or something. So this is guarding the while loop. We're not going to go any further once we reach the sentinel. That's what while loop with sentinel is. Counter, been there, done that. A counter tells you how many, 1, 2, 3, 4, 5, yeah. Running total, yeah, that goes 5, 10, 20, adding up different numbers rather than ones. Nested statement blocks. Well, I kind of slipped that up on you without even preparing you for it, didn't I? Nested statement blocks. That's indented statements inside indented statements, and maybe even more indented statements. Just indent goes further and further across the screen. What on earth? Here are our nested statements, our nested statement blocks. A statement block is a fancy computer word for a group of statements that are all indented by the same amount. Okay, looking at the entire program, starting with def main, DEF, the D of DEF starts in column 1. Everything else that we want to have inside our main program has to be indented by at least one tab space over. And again, the editor helps you do that. You don't have to remember to do it, you just have to let the editor help you. So everything past def main until we get to main clear down at the bottom, everything is indented by at least that amount. Why do I say at least? Well, if you want to be inside the while loop, if you want to be, more technical terms, part of the while loop statement block, then you have to be indented another notch over, another tab space over, after the while statement. So everything on my printout here, everything between blank line 30 and blank line 43, all of that stuff, 31 through 42, those are all indented by at least the same additional amount to tell the compiler that those are the statements inside the while loop. We would say that those are nested statements. Those are nested indented statements. A nested statement block because it fits completely inside the main program. Our while loop has to be completely inside the main program, but it's nested because it's indented even more. Well, wait, there's more. Look at the if-else. Line 34, the negative count equals negative count plus 1. That's the most indented statement in the entire program. Indented the same amount as lines 38 and 39, positive count and positive total. Those are nested inside an if-else, inside a while loop, inside a main program, in the hole in the bottom of the sea. It just gets deeper and deeper. There's more and more stuff added on. What does nested mean? Well, if your mom is a chef, or thinks she is, or your dad, then you might very well in your kitchen have a set of nested mixing bowls. Nested mixing bowls where they all look about the same, but there's a little one inside a slightly bigger one, inside an even bigger one, inside a great big one, and so on down the line. They all fit inside each other completely. It's not like their interiors overlap or anything. The little one has to fit completely inside the next size. Then that one has to fit completely inside the next bigger one, inside the next bigger one. That's what's going on with nested statement blocks. The tiny little mixing bowl are an example of that would be lines 38 and 39. Those are nested the most. That's the smallest mixing bowl. That fits completely inside the medium-sized mixing bowl, which is the indented statements for the while loop. The while loop indented statements all fit completely inside the biggest bowl of Python statements, which is the main program. So we've got different levels of indentation depending on how many things it's inside. In our case, in this program, the most nested, the most highly nested, are inside the main program, inside the while loop, inside the if. Or, alternatively, inside the main program, also inside the while, also inside the else. That's why those else statements are indented so much. They have to be. That is part of the Python syntax. That's as much a rule of the Python language as you got to have def before the word main on line 16. And that is the last of the bullet pointed comments in the header. So I'm going to say that we've done that. And again, this stuff is so important. Please look back through this carefully. Maybe try it with your own set of numbers, trace through it, because you got to be able to trace code. If you can't read somebody else's code, you're not going to be able to write your own, especially after things get more complicated. And I'm not trying to scare you, I'm trying to motivate you. I'll see you online.